In this question, we are told that figure 1 shows a block with a graduated side and of dimensions 4 centimeters by 4 centimeters by 16 centimeters. Just about to be lowered into a liquid contained in an overflow can. So here we've got the liquid and here is the block. When it is lowered into the overflow can, the displaced water will be collected in this can and we will be able to measure the mass of the displaced water. We are told that during an experiment with this setup, the following information was recorded. The block floated with 3/4 of it submerged. I'd like us to remember that this is a block which is floating. It actually floated. The initial reading of the balance is 0 grams, and then the final reading of the balance is 154 grams. From these two, we are able to calculate the mass of the liquid displaced. We are now asked to use the information to determine the density of the block as well as the density of the liquid. The mention of the word density brings into mind the need to determine the mass of the object as well as its volume. For example, since in this question we are asked to determine the density of the block, we can be able to determine its volume from its dimensions because it is a cuboid. So the volume of the block will be given by its length times width times height, and this is 16 centimeters times 4 centimeters times another 4 centimeters, and this gives us 256 centimeters cubed. This is the total volume of the cuboid. We are told that the mass of the liquid displaced is 154 grams. Since the block floats, it will displace its own weight of the fluid in which it floats. This is according to the law of flotation. The law of flotation states that a floating body displaces its own weight of the fluid in which it floats. That is, the weight of the object in air will be equal to the weight of the fluid displaced. The fluid in this case is the liquid. So the weight of the liquid displaced can be calculated. So weight is equal to mg. Now we know that the mass of the liquid displaced is 154 grams. This is the same as 0.154 kilograms. And then we multiply this by the value of the gravitational field strength, which is 10 Newton per kilogram. And this gives us 1.54 newtons. This is the weight of the liquid displaced. According to the law of flotation, the weight of the block is also 1.54 newtons. So weight of block is 1.54 newtons. Now this implies that mass of the block can be worked out. Remember, the reason why we want the mass of the block is so that we can divide it by its volume to get its density. So mass of the block will be equal to weight divided by the gravitational field strength, and we'll have 1.54 newtons divided by the value of the gravitational field strength, which is 10 Newton per kilogram. And this gives us 0.154 kilograms. which is equal to 154 grams. So we have the mass of the block as well as the volume of the block. These two physical quantities will enable us to calculate density of the block. So density of the block is equals to mass of the block divided by volume of the block, and this is 154 grams divided by 256 centimeters cubed. And this of course gives us 0.601 grams per centimeters cubed. Let me go through this calculation once again. Why do we need to calculate the volume of the block? We are prompted to calculate the volume of the block from the fact that we are required to calculate the density of the block. In order to calculate the density of any substance, we need two physical quantities. One of them is the mass of the substance, the other one is its volume. So when we look at the block, since it is a cuboid, we can immediately calculate its volume by multiplying length by the width and by the height. That gave us 256 centimeters cubed. The next task is to find the mass of the same block. This comes from the fact that the block is floating. We immediately recall the law of flotation, which states that if a body is floating in a fluid, in this case it is floating in a liquid, then the weight of the liquid displaced will be equal to its own weight in air. Now we are given the mass of the liquid displaced, which is 154 grams. So we convert the mass of the liquid displaced into newtons using W is equals to mg, which is 0.154 kilograms times 10 newton per kilogram. We get 1.54 newtons. This is the weight of the liquid displaced. And from the law of flotation, the weight of the block is 1.54 newtons. At this point, we recall the relationship between mass and weight. And this is the relationship. Mass of the block is equals to weight of the block divided by the gravitational field strength at that place. And that is how we got the mass to be 0.154 kilograms, which is of course 154 grams. Now we have the two physical quantities that we were looking for, its mass and its volume. So we quickly go ahead and divide the mass of the block by its volume to get its density. Of course, we can go ahead and convert this density into kilograms per meters cubed if we so wish. Now let's see how we calculate the density of the liquid. Now we are told that 3/4 of the block is submerged. That means the volume of the liquid displaced is equal to 3/4 of the volume of the block. So we get 3/4 of 256. Three-quarter of 256 will give us 192 centimeters cubed. We already know the mass of the liquid. Therefore, it's very easy to calculate the density of the liquid from mass divided by volume, which is 154 grams divided by 192 centimeters cubed. And this gives us 0.8 grams per centimeters cubed. So the second part is very easy.